Jai Bharat. Welcome everyone to Advait Achievers. Pranam to all of you. As we believe, Vidyarthi Devo Bhava. So till now we have learnt about the mechanism of muscle contraction, and we know that during muscle contraction, for that actin myosin cross bridge formation, ATP is required. So in this video we are going to talk about the energy for muscle contraction. जो ये energy लगती है muscle contraction के लिए, वो कहाँ से आती है, कैसे आती है? So that we are going to understand. So children, say in the vertebrates and few invertebrates, there are substances which provide energy. अब यहाँ पे हम बात कर रहे हैं कि constant ATP supply की ज़रूरत है ना? तो वो कहाँ से आएगा? That is what we are going to talk. So as I said, that in vertebrates and few invertebrates. In vertebrates and a few invertebrates. Substances that provide energy are called phosphagens. Substances that provide energy are called phosphagens. What are they called? They are called phosphagens. So, in case of vertebrates and a few invertebrates, which are the phosphagens? One is, of course, we know that we are utilizing ATP. तो एक phosphagen जो है वो ATP है, पर जो दूसरा है, the other one is phosphocreatine. Phosphocreatine, or you call it creatine phosphate. It is phosphocreatine or creatine phosphate. तो ये जो पूरा एनर्जी है, ये कांस्टेंट एनर्जी सप्लाई जो होना चाहिए, एटीपी का सप्लाई होना चाहिए, वो कैसे हो रहा है? That we are going to understand in this segment, right? So we'll be taking it step by step, okay? So say first step, we know that ATP is hydrolyzed. ATP is hydrolyzed. So say we put that up into the form of a reaction, that ATP is converted into, we know, ADP and inorganic phosphate, and it releases energy, right? Right? It releases energy, right? This energy, ये generate होने के लिए what is required? We know ATPase is required, and this ATPase, who acts as this ATPase? We know myosin head. तो मैं यहाँ पे भी add कर रही हूँ, myosin head acts as this ATPase, and this hydrolysis of ATP has taken place, which releases energy. Now this energy is used for actin myosin cross bridge formation, used for actin myosin cross bridge formation, right? This is clear? Yes. Now ये हमारा फर्स्ट फॉस्फेजन हो गया. अब दूसरा ले रहे हैं क्रिएटिन फॉस्फेट, क्योंकि उसके साथ ये जो हमारा ADP बना है, that is going to join. So let us take the next reaction, that creatine phosphate it combines with this ADP, right, and it gets converted into ATP. मतलब इसके पास जो अपना फॉस्फेट था वो इस ADP को दे रहा है, सो ADP इज गेटिंग फॉस्फोराइलेटेड फॉर्मिंग ATP, ठीक है, एंड तो बचा क्या, क्रिएटिन, सो ATP एंड व्हाट इज फॉर्म्ड, क्रिएटिन. समझ में आया, राइट, एंड द एंजाइम रिक्वायर्ड फॉर दिस इज क्रिएटिन क्रिएटिन काइनेज. Right, creatine kinase is required for this, correct. Now glycogen is converted to glucose, that we know. We have learnt कि the liver stores the excess of glucose in the form of glycogen. So glycogen, when required for energy purpose, it gets converted into glucose. glycolysis की process होगा फिर, है ना. तो ग्लाइकोजन, ये ग्लाइकोजन लीवर में भी स्टोर होता है और मसल सेल्स में भी होता है, ठीक है. सो ग्लाइकोजन इज कन्वर्टेड टू व्हाट, ग्लूकोज, करेक्ट. दिस ग्लूकोज से बाय एनारोबिक रेस्पिरेशन gets converted into lactic acid, and we know energy is released. अब इस lactic acid का क्या करेंगे, right? So most of the lactic acid goes to the liver. मसल, ये हमने जो बात करी है ये मसल की बात करी है. मसल के अंदर जब मसल कॉन्ट्रैक्शन हो रहा है उसके लिए एनर्जी चाहिए. I said glycogen is stored in muscles also. So this glycogen is getting converted to glucose, which undergoes anaerobic respiration to produce lactic acid. Lactic acid and energy. अब इस lactic acid का क्या होगा? Accumulation तो muscle fatigue करता है. We know that, right? So most of the lactic acid goes to the liver. Most of the lactic acid goes to the liver, ठीक है. और वहां पे जाके क्या, चलो वो देखते हैं. तो lactic acid, okay, in the liver, 4/5 portion goes say in the liver. 4/5 of it, that again gets converted to glycogen. वापस कहाँ पे, and then stored in liver. Correct. And 1/5 which has remained, that 1/5 which has remained, उसका क्या होगा, right? That is combining with carbon dioxide plus, or you can say it splits into carbon dioxide, water, so energy is released, right? This energy is used to generate creatine phosphate. This energy which is formed is used to generate creatine phosphate. Understood? So say we can take one more step to understand that. Say in the 5th step, ये energy, ठीक है, this 1/5 of lactic acid is converted into carbon dioxide, water and energy. Right? This energy is used for what? To form और जनरेट क्रिएटिन फॉस्फेट. कैसे? अब देखो यहाँ पे भी क्रिएटिन बना पड़ा था, फ्री पड़ा था, तो ये क्रिएटिन, ये एनर्जी और इनऑर्गेनिक फॉस्फेट जो एटीपी के हाइड्रोलिसिस के टाइम से भी होता है. सो क्रिएटिन plus that energy plus that inorganic phosphate, correct? That combines, or the energy is being used to combine this creatine and inorganic phosphate to form creatine phosphate. So this is how a constant supply of phosphagens is maintained so that ATP is constantly, or say energy, rather more of these you should say, energy is constantly being supplied or is available for muscle contraction. Right? Hope you all have followed. In the next segment we will be talking about Cori's cycle. Thank you.